or don't use any shortcuts, which I did because I thought it was just safe and it would just kill the algae. Oh, by the way, the snails also died. Every bit of snail that was in there that was cleaning up that tank also died. Good morning, you YouTubers. The other month I had an outbreak of red slime in this tank here. The CLOWNFISH hotel tank. It was particularly in a couple of hotel suites back here, just in the middle, two sections that got the most light. And it would go away. So I recall that I had some red slime remover many years back. So I looked for it, and I did find it. Red slime remover. Remove slime safely and effectively from corals and invertebrates. Box looks like that. What's inside is a yellow looking compound. Direction says mix thoroughly 1 teaspoonful for each 15 gallons of aquarium water with a small amount of water. Then add medium to tank. For aquarium use only, keep out of reach of children. So that's the only thing that says on there. Remove slime, red slime, quickly from corals and invertebrates. Nothing else, just that. So it has directions how to use it. A little bit mixed with a little bit of water and just put in to the aquarium. So I did that. That's a couple months back. Then I forget about it. And maybe a couple weeks later, I buy a rose bubble tip anemone. I put it in the tank, thinking that the clownfish would love that. I mean, which clownfish would not like it? Water is crystal clear. The red algae is starting to disappear. Well, by this time, the red algae has disappeared a lot. So I put the red rose tip bubble anemone in the tank, and then immediately, a day after that, it started to die. I didn't know what was going on. I didn't even think about what I did to the tank. I didn't think about how I put that in the tank. But by this time, when an anemone starts to die and starts to tear apart and starts to be a little bit goopy, by that point it's too late. It's too late to save the anemone. So I had to throw that away. Just 2 days within buying the anemone, it dies. Learning experience. So I started thinking, well, maybe it's the water chemistry. Maybe I should have checked it just to make sure the pH, the alkalinity, the phosphates, the ammonia is not affecting the tank so much. Then a couple of days later, I started to read this here. In the back of it, Ultra Life Red Slime Remover is a revolutionary time-tested product. Ultralight RSR contains natural cellular matter Selective biological accelerators and special supplements proven effective in removing red slime from corals and invertebrates. For best results, do not turn off UV sterilizer or ozonizer. Ozonizer. Continuation of protein skimming is recommended but may require adjustment. Due to increased biological digestion of organic solids, that means that the red slime is being eaten up. Um, Organic solids could also mean fish waste. We recommend increasing your O2 levels by addition of air stones prior to and during treatment. No need for water changes or removal of carbon filtration. Underneath that it has directions. And then underneath that it says treats up to 300 gallons. Contains no algicides or erythromycin succinate. Algicides, meaning it kills algae. Contains none of that. Or erythromycin succinate. Erythromycin is an antibiotic. Keep out of reach of children for aquarium use only. And then very, very bottom, may affect pH and oxygen levels. I didn't read that. So by affecting the pH and oxygen level days after treatment, it could have affected the livelihood, the livability, I think that's what killed the anemone. Sad to know. Should have been more careful. But my mistake is a learning experience for you. So now I'm trying to put back the oxygen level in the tank by running a little bit of oxygen and air bubbles in there. I have also changed the water just to get some of that out if there is any bit of that red slime remover still in there. So what is the lesson here? The lesson here is not all warnings and suggestions are complete within the bottle that's inside the packaging. Read the packaging on the back. First and foremost, don't skip or don't use any shortcuts, which I did because I thought it was just safe and it would just kill the algae. Oh, by the way, the snails also died. Every bit of snail that was in there that was cleaning up that tank also died. So, oxygen level and pH is affected. Those that go out of whack, those that really need their pH levels at a steady level and oxygen at a steady level will be affected. Now the clownfish didn't die because they're pretty hardy. They're able to live in a wide range of levels. So even a swing of the pH or oxygen level wouldn't affect the clownfish too much. If it did, I would have seen some of that effect, but I did not. Sad? Yeah, it's sad. In this hobby, things will die, things will grow, things will be replaced. Just the nature of the hobby. You can't deal with the swings and death of corals or fish. It's not the thing for you because it is an expensive hobby. But it's well worth it. It's very rewarding. So I'll keep that up for maybe a couple hours, maybe a day. I don't know. Maybe I'll give a lesson on how pH and oxygen level affects fish. I tested my aquarium water using the API test kit. and also a refractometer. I will go over the results first before I go over the ideal parameters of a given fish tank, whether it's reef related or just fish only. My specific gravity using the refractometer came out to be 1.0175. My pH using the API system and following the information given by the manufacturer came out to be in the range of 7.5 to 7.8. In back of the API information pamphlet, you'll see results according to their color. My pH, as you can see, is between the range of 7.5 and 7.8. And going along the same line, using the color-coded chart in the back of the information packet, my ammonia, oh, I see what I did. If I would line that up correctly, there we go. That's pH, 7.5 to 7.8. Ammonia is yellow, 0 ammonia. Nitrite is 0. Nitrite, which can be deadly to fish and corals both, is 0. My nitrate, this range is above the given range that's in the chart. It's above 160 parts per million. So which is no good, which means there's a lot of waste and detritus, and that's not being taken care of. So anything that's dead, any uneaten food, decomposed food, that's going to raise your nitrate level. The temperature of my tank is about 80 degrees, which is pretty ideal. And at that temperature, the ideal specific gravity of a saltwater tank should be between the range of 1.021 and 1.026. And mine is 1.0175. So what does that mean? What is specific gravity? Specific gravity is a measure of how dense. So the denser the water, which means the more salt there is, the more dense there is, the higher the specific gravity. So right now I don't have the perfect match of salt and water, which means I just have to add more salt into the tank to raise that specific gravity to the ideal range between 1.021 and 1.026, which is an easy fix. Dissolve a little bit of salt, add it to the tank. The ideal temperature, if you have a fish-only tank, is between the range of 78 to 82 degrees Fahrenheit. And if you have a reef tank, it's anywhere between 75 and 78 degrees. For clownfish, it's in the range of 72 to 78. And if you're breeding clownfish, it's even higher, just above 80 degrees Fahrenheit. So let's talk about pH. The pH of my tank is between 7.5 and 7.8. So pH is an indication of how acidic and how basic a solution is. That solution being tank water. In a reef system, the ideal pH is between the range of 8.0 to 8.4. So this is more of a basic solution. Neutral is 7. So anything above 7 is basic. Anything below 7 is acidic. That's just basic chemistry. So how do you raise pH and how do you lower pH? So in critical situation, when your pH is very low for a long time, you can actually raise that pH with a quick fix by adding carbonates, calcium carbonate, sodium carbonate, just regular baking soda. Quick fix, baking soda, carbonate. Now, if your pH is extremely high and you need a quick fix, lemon juice will give you a quick fix. Vinegar also will give it a quick fix to lower that pH level. So depending on your range and where you want to be, what type of system you have, whether it's reef or just fish only, change that range, fix that range accordingly. So what are acids in your system? Carbon dioxide is an acid. Carbon dioxide is given off during respiration when fish are breathing. Nitric acid is acid, just in the name itself. This is a result of biological filtration. Biological filtration, meaning the bacteria that eat up and create waste themselves, convert that into to acid. It's a byproduct of bacteria digestion. Other acids include organic waste, organic acids, which is the result of fish waste, decomposing food that is left in the aquarium. So it's very important that any food that is uneaten be taken care of it pretty quickly. Let's go over the nitrogen cycle just a little bit. Food is given to the fish. The fish create ammonia as a waste. The waste is eaten up by bacteria, and the waste is converted to nitrite. Nitrite is actually pretty dangerous to fish and other livestock. The nitrite itself can be converted to nitrate, which is still bad but less dangerous than nitrite. The end product, nitrate, is the result of decomposing food and fish waste. However, this can be food for plants. Nitrates are good for plants. You put nitrates in your garden will grow. If you have high nitrates in your system, algae will grow. Other bacteria will grow. So that is the nitrogen cycle itself. So starting a new system, you have to let the nitrogen cycle take care of itself. If there is no fish in your system, all these parameters should be 0, except pH. pH should be ideal to the inhabitants, whether it's fish or corals. And as a reminder, if you're doing corals, it's 8.0 to 8.4. Now fish can withstand a pH that's lower than that, 7.4 to 7.8. There are compounds that can buffer the pH of a system. A buffer system retards the drop of pH. So a little bit of acid will not lower the pH. If you add a little bit of acid to the system, it will not lower the pH dramatically. So that buffer system is the ability of the system to withstand quick changes in pH. So if you add more acid or more basic, the pH doesn't change much. So that's a buffer system. And what buffers the system are compounds like bicarbonate, calcium carbonate, borate, hydroxides. These are natural buffer of a given system. So if you see a system that has that the pH is out of whack, let's say a lower pH, you know that the buffer is no longer active. There's no buffer. So what do? Trying to raise the pH. You could add more bicarbonate. Baking soda is a bicarbonate. That will raise the pH to the ideal pH level. If your pH is too high, you have too much calcium. Too much calcium can raise the pH level. So what do? You add more lemon juice and you add more vinegar to lower the pH to the ideal level. For a clownfish system, like what I have here, the ideal parameters for pH is anywhere between 8 and 8.4. And in my test, I'm in a range of 7.4 to 7.8. Need to raise the pH, so I can easily do this by adding baking soda, which I would do. My temperature is about 80 degrees, which is ideal. Now, if I'm trying to breed clownfish, which I'm trying to do, I need to raise the temperature above 80, meaning adjusting the thermometer to a higher temperature. My specific gravity ideal for a system for clownfish is 1.021 to 1.026. I am at 1.0175. Easy fix, just add more water, mix it up, dump in the system. That'll raise your specific gravity. That'll raise your density of that water. Now earlier I talked about my red slime algae issue. And I had an outbreak of red slime, and I used a red slime remover. So what is red slime algae? Well, red slime algae is actually a misnomer. It's not an algae. It's a bacteria. Specifically, its scientific name is CYANOBACTERIA. Cyano is a color red bacteria. So how does it grow? High phosphates and high nitrates make this bloom. Also, lack of flow and old lighting. You might think, well, what does lighting have to do with it? It's a spectrum of light. When the lighting gets old, the spectrum changes, and it increases the likelihood of red algae to grow. With lack of flow, you can easily add a power head to move the water. With old lighting, the spectrum of the light changes, and when this changes, it's beneficial to bacteria. It's beneficial to red algae. So make sure you change your lighting fixtures. Change your bulbs, your T5s, your fluorescents. Those small things can easily fix your problem with red algae. And if you want to go to the extreme, you can use chemicals like red slime remover. But make sure you read the packaging on how to use it. With red slime remover, remember to add oxygen to the system before you add the red algae, and also add oxygen after you add the red algae remover. So that's it for today's lesson. I hope you gain a little bit of knowledge on biology and chemistry of a healthy aquarium, a healthy saltwater aquarium. The basic testing knowledge, what you're testing for. You're testing for pH, nitrate, ammonia. These are important and basic chemistry, and it's important to keep them in a certain range in order for your livestock and your corals to be healthy, to maintain its color, to maintain its growth. Also, I hope you learned a little bit about red slime. What red slime is. Not actually an algae, but a bacteria, and it can be dealt with. Bacteria feast on phosphates and nitrates. So if you keep those levels low, by mechanical filtration or by biological filtration, or by just manually removing the waste products, the uneaten foods. These are simple things and more common sense things to help keep your reef system, to help keep your fish staying healthy. So until then, subscribe below, comment, and also follow our Instagram. Thank you for watching.